Hi everyone, my name is Connie Desai, and this presentation is about bodies in space. Also, this channel is part of a non-profit organization called One World, One Nation that strives to support children globally who lack educational resources or are disadvantaged. By providing these students with an extended learning platform, they can explore their interests, build on their passions, and find a path to a career. Please subscribe to this channel and like this video to support our initiative. The information for our organization is in the description box below. To start off, there are many things in space, many more than we could discuss in one video. So the objects you learn about today are just a fraction of the things that you can learn about. The first objects that we'll discuss are comets. Comets are masses of rock, dirt, ice, and gas. They can leave trails behind them, resulting in the streaks you see during meteor showers. Comets break apart into small pieces when they enter the Earth's atmosphere, which is why you see multiple streaks during a meteor shower instead of just one. On a separate note, comets can be a reoccurring or a one-time sighting. For example, the Halley comet is seen from Earth every 75.3 years. The next time it's expected to be seen is 2061. Next, we have asteroids. An asteroid is a rocky object that orbits the Sun. They're very small compared to planets. Between Mars and Jupiter is the asteroid belt, and the asteroid belt is where most of the asteroids in our solar system are located. Asteroids are essentially leftovers from when the solar system was being created. They stay in the asteroid belt because they're held by Jupiter's gravity. Without Jupiter, many more asteroids will hit the Earth each year. One of the biggest objects in the asteroid belt is called Ceres. It has a diameter of 592 miles, which is almost 1/14 the size of Earth. And we have meteoroids, meteors, and meteorites. They're commonly mixed up. A meteor is a light that you see when a meteoroid enters the atmosphere. A meteoroid is a rock-like object that comes from a comet or asteroid. A meteorite is a part of a meteoroid that passes through the atmosphere and is found on the surface of the Earth. A famous meteorite is called the Peekskill meteorite. It landed on a car in New York in 1992. The car is now famous and has been seen all over the world. During most of their lives, stars radiate energy. One star that is a main sequence star, or is in the main part of its life, is called a yellow dwarf star. Our Sun is a yellow dwarf star, meaning that it is in the phase of its life where it can still radiate energy. The Sun is 4.5 billion years old. It's predicted to radiate energy for another 5 billion years before turning into a red giant. But what exactly is a red giant? When a main sequence star runs out of energy, it starts to collapse or shrink. As a result, it gets hotter. The heat goes to the outer layers of the star, causing it to expand, and then becomes cooler because there's more space for the heat. The cooled star becomes red instead of yellow because cooler things appear redder, while hotter things appear bluer. For example, if we were to look at different flames, blue flames would burn hotter than red flames. The same principle applies to stars. Therefore, the cooler star becomes red instead of yellow. So the larger size and the red color contribute to its name as a red giant. When the red giant gets too hot, it collapses. As a result, a nebula is formed. A nebula is a cloud of gas and dust. From nebulae, which is the plural form of a nebula, new stars are formed. Since the nebula in this example is formed from a star, it contains the same elements that make up a star, hydrogen and helium. Over time, gravity gathers the dust and gas up. Once the collection of gas and dust gets too big, it collapses, which heats up the center. The result is a new star. After becoming a red giant, a star can become a white dwarf star. White dwarf stars are really small, but also extremely dense. That's because they contain the same amount of matter or stuff, but in a smaller amount of space. White dwarf stars fade out and cool over billions of years. The smaller stars turn into red giants. Larger stars turn into red supergiants. They only last for 1 million years and slowly become heavier. They become heavier because iron builds up in the core. Stars fuse hydrogen to form helium. As a star becomes a red supergiant, it runs out of hydrogen and as a result has to fuse heavier elements. The result of that is that iron builds up in the core of the star. If a red supergiant explodes, it causes supernova. Red supergiants explode because they use more energy than they can produce. It cannot sustain that cycle and as a result explodes. As a result of the explosion, nebulas can be formed. Different nebulas appear differently depending on the materials that they're made up of. Sometimes when a red supergiant explodes into a supernova, a neutron star is created. A neutron star is about the size of a city and is extremely dense, even more dense than a white dwarf star. When you think about the size and scale of stars and planets, a city is very small. Therefore, there's a lot of matter in a very, very small space, resulting in a high density. In a neutron star, there's a lot of gravitational force. As a result, protons and electrons are combined, producing neutrons. That's how the name of the neutron star came to be. The scale of neutron stars and their density make them different from other stars. When really big stars die, black holes are created. The star collapses and what's left is gravity. The force of gravity in a black hole is so strong that not even light can escape. That's why you can't see anything in a black hole, because light is needed to see. What happens if you get sucked into a black hole? Spaghettification would occur. You get stretched out really long because of the high gravitational force. Beyond spaghettification, scientists don't really know too much about what black holes do. They are an ever-present source of mystery that we might never solve. But who knows? Maybe you'll discover the secret of black holes.